Hello students, welcome to Shri classes. We'll begin with a new chapter in mathematics, that is chapter number 12, areas related to circles, lecture number 1. Before we proceed to the areas related to circles, definitely we need to understand some terminologies associated with circles, such as the different lines that pass through the circles, then the segments, then the arcs, then the sectors. So if we understand these things, it would be easier to proceed further. To begin with, there are some terms which are related to intersection of a line and a circle. So if you look at this one, APB, it is a tangent, CD is a secant, and EF is the diameter, GH is a chord, and OK is the radius. Now the main difference between secant and tangent is, secant is a line segment or a line also we can say, which intersects the circles at 2 points. So there are 2 points of intersection, this one and this one. Whereas if you look at the tangent is a special case of a secant where it intersects the circle at only 1 point. That means the 2 points of intersections will merge to a single point. So this is AB is a tangent and it touches the circle at point P, and P is called the point of contact. So rest of the things are easy. GH is a chord here, EF is the diameter, and diameter is equal to 2 times R. If I assume OK as the radius equals to R, then diameter should be equal to 2 times R. Anything else? That's all in this. Next one, segment. A chord AB divides the circle into 2 parts. That is one smaller part and one is the bigger part. The region bound by the arc, or I can say the region bound by a chord and a corresponding arc, is termed as a segment. So the region bound by the chord and its corresponding arc, this is a smaller arc and this is one more bigger arc. So the region bound by the segment and the smaller arc APB, this region is called a minor segment. Similarly, the region bound by AB chord and the major arc AQB is called a major segment. So the smaller part, this entire region, this is called a minor segment, and the major part, this is called a major segment, which are represented by APB and AQB. Coming to the arcs here, if you take any 2 points on the circle, the 2 points will divide the entire circumference of the circle into 2 parts. One could be a smaller part and one could be a bigger part. The smaller part represented by arc length APB, this one is called the minor arc. Similarly, AQB, this part of the circle from A to B, this is called the major arc. AQB is a major arc. And how do you represent the arc lengths? Arc lengths are represented by this particular curved line over the letters. Say for example, if I represent AB something like this, it specifies that this is an arc between the points A and B, and it is basically the arc length. So you can see the 2 arc lengths here, minor arc and a major arc. Now between this and this, what is the difference here? Arc lengths are the parts of the circumference, parts of the circumference. Whereas here this is basically, segment is referred to a region bound by a chord and a corresponding arc. Means it is related to the area basically. Segment refers to particular region, whereas arc refers to only the part of the circumference. Here also, which chord divides the circle into 2 exactly or 2 equal halves? The diameter is the largest chord and the diameter divides the circle into 2 equal segments. Similarly here, if I take the diameter, the diametrical end points divide the entire circumference into 2 equal halves. Next comes the sector. See here, the meaning of sector here is again, it is the region. Sector is the region bound by 2 radii and a corresponding arc. The sector is the region bound by, sector is the region bound by two radii that originate from the same point, two radii and arc length AB. So this region is called a minor sector, and from here to here, this entire region is called a major sector. This one. I hope you are able to understand. So this one, which is indicated by red, this is a major sector and this is a minor sector. If theta is the angle subtended by the arc length APB at the center, or if theta is the angle of the minor sector, then 360 minus theta, which is the reflex angle, is the angle of the major sector. That you should remember. So what else is there? Sector understood. And generally, by default, when I say a sector, it refers to the minor sector. Remember, by default, if I say a sector, it refers to the minor sector. So first make a note of all these things, then we'll proceed to the circle and what is the value of pi, how to calculate the area of the circle, area of the sectors, then area of the segments. This is our topic of discussion. Note down first. Now we'll see, with respect to circle, what is the circumference and what is area, the formula for circumference and for the area. So first one, the perimeter of the circle. Of course, the perimeter is called the circumference, isn't it? So the entire perimeter of the circle is the circumference. Here it is a circle with diameter d and radius r with center O. AB is the diameter and OC is the radius. So perimeter is equal to circumference, and remember, the ratio of circumference to the diameter is constant, and that value is called pi. So what is the value of pi? The ratio of circumference, this is applicable for any circle. The ratio of circumference to the diameter is constant, and that value is called pi. So if I represent the circumference by C and the diameter by d, then C by d equals pi, and therefore circumference is equal to pi into d, whereas diameter is equal to 2 times r. Therefore pi into 2r is nothing but 2 pi r. So the formula for circumference is 2 pi r. Next, a couple of informations which if you can remember, it is good. See, the value of pi, which we know that it is 22 by 7 nowadays. We know the approximate value of the pi is 22 by 7 or 3.1416. Importantly, Aryabhatta, which was the Indian mathematician, he found out the value of pi as 62,832 divided by 20,000. That gives you about 3.1416. For all practical purposes, in terms of the decimals, 3.1416 is pretty good value. So also Srinivas Ramanujan, Srinivas Ramanujan, everyone must have heard about his name. I hope all of you know who was Srinivas Ramanujan. He was of course the greatest Indian mathematician. See, about 120 or 150 odd pages have been written by him, out of which so far we are able to crack about 80 pages. Still there are many more pages in his notebook, which is in the form of PDF, and nobody has understood what are those things which have been written by Mr. Ramanujan. So Srinivas Ramanujan, he gave the value of pi correct to million places of decimal. That means after the decimal point, the accuracy of the value of the pi was up to 1 million places. That is 1 million is 10 lakh. Up to 10 lakh places, the accuracy of the decimal places was there. So yes, Ramanujan gave the value of pi correct to the million places of the decimals. And what else we want? That's all. Basically, for the time being, you need to remember that circumference is equal to 2 pi r. That is the thing. Now, how to calculate the area of the circle? One rough estimation. This is how we can calculate the area of the circle. The entire circle can be divided into smaller and smaller and smaller, arcs, smaller and smaller sectors. See, if we divide the entire circle into smaller and smaller sectors, then you cut those pieces and join in this form. Say for example, this circle has been divided into 16 pieces now, and cut this piece, keep it like this. Cut second piece and keep it this way. So if I arrange all these 16 pieces which have been cut into 16 parts, if I arrange, I'll be able to get something like this, a rectangle. The width of the rectangle is r, the radius from here to here it is, from here to here it is radius r, and this is the basically the length. See, how did I get this length is, how many pieces are there on the top side? 1, 2, 3, 4, 5, 6, 7, 8. If I add all these arc lengths, this is nothing but half of the circumference. Similarly, if we add these arc lengths, you will get another remaining half of the circumference. So from here to here, basically the length is half of the circumference, and therefore we write it as half of 2 pi r. So what is the area of the circle now? Area of the circle is nothing but here, if I assume this to be a rectangle, then its length into breadth. The breadth is r here, radius, and the length is half into 2 pi r. Therefore area of the rectangle is half into 2 pi r into r. This is the length and this is the breadth. So finally 2 cancels, we get pi r square, and hence we say area of the circle is pi r square. Very interesting to know, isn't it, how to calculate this also. See, these pieces can be broken down into so small that almost these arc lengths will be a straight line. That way we can divide it. So the concept of calculating the circle is the same. More and more, if you divide the circle into smaller pieces, more accurate. But anyway, we know that from here to here there are 8 pieces, because half the circumference, and therefore it is half of 2 pi r. And on the top also there are 8 pieces, and half the total length is half the circumference. So in order to find the area, it can be assumed to be a rectangle of breadth r radius and of length half of the circumference, and then you can calculate, multiply these two to get the area of the circle. So make a note of this one, and then we'll proceed to the area of the segment, area of the sectors. First make a note. Now we'll take up the sector and find out the formula for area of the sector and the arc length of the particular sector. Arc length also we will try to find out. A circle with radius r here, radius r, this also is r, and a center O. A sector AOB is considered with angle theta. So APB is the arc length of this sector. Whenever I refer to the sector, please try to remember that by default if I say a sector, it is a minor sector. Okay, that is important. So how to find out this, the area of this minor sector? First I'll write the formula and then try to explain to you what is the, how to find out the formula. See, area of the sector is given by area of sector AOB, or I can say OAPB, that is better. OAPB, it is a minor sector which is equal to theta by 360 into pi r square. How did you get this one? See, if theta is complete angle, that is for 360 degrees, then the total area of the circle is pi r square. So by unitary method I can adopt here. Here let it be angle and area. For 360 degrees angle, the area of the circle is, we know it is pi r square. For theta, let it be x. How much is this one? Or you can say A also, area. A is the area. So cross multiply, you will get it. A into 360 equals theta into pi r square. Theta into pi r square. And therefore, area is equal to theta by 360 degrees into pi r square. So this is how we can calculate by the unitary method. So this formula, make a note of this one. Area of the sector is given by theta by 360 into pi r square. This is a minor sector because we found out this area. How to find out the major sector area? Simple here. For to find out the major sector area, we must know this as the angle. What is this angle basically? This angle is the reflex of theta, which is nothing but 360 degrees minus theta. So this is called the reflex of theta, reflex angle of theta. So area of major sector is equal to area of sector AQB or OAQB. I'll write OAQB is equal to 360 minus theta divided by 360 degrees into pi r square. So this is how we can find out the area of the major sector and also area of the minor sector. Please remember here, this is a minor sector, important. Minor sector. Area of the sector OAPB is equal to theta by 360 into pi r square. Now comes the arc length. So here there are two arc lengths, minor arc length and major arc length. So let us find out the both arc lengths. Okay, let's find out the arc length here now. This is B. Which is the minor arc length here? Arc length APB is the minor arc and arc length AQB is the major arc. So minor arc length is given by APB, which is equal to theta by 360 into circumference 2 pi r. So this is the formula. How do you get it? By unitary method. For 360 degrees, 2 pi r is the circumference. For theta degrees, how much it is? Theta by 360 into 2 pi r. Similarly, major arc length. Major arc length. What is the major arc length? AQB is given by, what is the angle here? This is 360 minus theta, which is nothing but the reflex angle. So 360 minus theta divided by 360 into circumference 2 pi r. So note down these two formulae also along with the area of the sector. So how many formulae we looked into? Very important. See here, this is area of the minor sector, here r square, okay, pi r square into pi r square. Area of the minor sector is theta by 360 into pi r square. Area of the major sector, here also this is square, okay, and arc length, this one is minor arc length and this one is major arc length. So these are the four formulae which you need to note down. 1, 2, 3, 4. Now while calculating here, one important thing, this while calculating the area, the value of pi generally is taken to be 22 by 7. See, 22 by 7 is only the approximation. Remember, 22 by 7 is only the approximation. Pi is an irrational number because it's a decimal expansion. If you look at, it is non-terminating and non-recurring. Whereas 22 by 7, it is a rational number because both 22 and 7 are integers, and integer divided by integer gives you a rational number. So how can we equate an irrational number to the rational number? Therefore you must remember the value of pi, or pi, even though it's an irrational number, the approximate value of the pi is 22 by 7. That we should remember. So two formula and also pi value. By default in our calculations, whenever they say calculate the area of the circle or area of the sector and all, if pi is involved, by default we assume the value to be 22 by 7 unless otherwise specified. Like 3.1416 also you can take, but provided they specify that. If they do not specify anything, in that case by default I'll be taking into my calculations as 22 by 7, and based on the situation I will try to switch over between 22 by 7 and 3.1416 also. So make a note of this area and arc length of the sector. Minor sector, major sector, minor sector, major sector. Please make a note this. Now let us take a segment. We try to find out now the area of the minor segment and major segment. Just to explain to you the diagram, OAPB is a sector and the angle made by this arc length APB, or the angle of the sector, is theta. Theta is the angle of the sector at the center. And join these points A and B and draw a perpendicular through the center OM. OM is perpendicular to this one. So OM, a perpendicular from the center, bisects the chord. So AB is equal to AM plus MB, or 2 times AM or 2 times MB. I hope that you are able to understand. Why this is theta by 2 and this is theta by 2? If this is the angle of the sector is theta, then the angle between the radius and this perpendicular through the center is theta by 2, because these two triangles are congruent. How is it so? In these two triangles, OA is equal to OB, radii of the same circle, and this is perpendicular 90 degree and 90 degree, and this is common side, right angle, hypotenuse and common side. By RHS congruency rule, these two triangles are congruent, and therefore this angle is equal to this angle. Therefore this is theta by 2 and this is theta by 2. I hope you are very much clear about the reason being theta by 2 and theta by 2 in both these triangles. Now next, area of the minor segment. What is that minor segment? This hashed portion, or which has been shown this way, this one, from here and this one. This is the major, this is the minor segment. So the area of this minor segment is area of this minor sector minus area of the triangle. Area of the minor sector we can very easily find out, because we know R and we know theta. Theta by 360 into pi r square gives you the area of the minor sector. What about the area of the triangle OAB? Let us try to find out the area of the triangle first. So in the top here I have written area of the minor segment, that is the hashed portion or the shaded region. The area of the minor segment is the shaded region, is equal to area of the sector OAPB minus area of the triangle OAB. So mark this equation as 1. I think I have to change the pen. Give me a black or something. Now let us find out this area of the sector and area of the triangle separately and substitute the values here. So let this part be 1 here and this part be 2 here. So first one, area of sector, OAPB is equal to theta by 360 into pi r square. Mark this as 2. Now second part we will work out, that is area of triangle OAB. This area we need to work out. So area of triangle OAB is equal to OAB, area of the triangle OAB is equal to half into base AB into height OM. So we do not know what is this OM, and also we do not know what is AB. Let me try to express height OM, which is altitude, and base AB in terms of R and theta, that is by trigonometric ratios. So listen very carefully. In triangle AMO or OAM, I'll say. Now in triangle OAM, okay, sin theta by 2 is equal to sin theta by 2. Theta by 2 is sin theta by 2 means sin into bracket theta by 2. I hope you can understand this one. This is theta by 2, like this it is. Sin theta by 2 is equal to opposite by hypotenuse, AM by OA, AM by OA, which is equal to AM by R, and therefore AM equals R into sine theta by 2. What is AM here? AM is this much. What about AB? AB is equal to 2 times AM because a perpendicular from the center bisects the chord, and therefore AB is equal to 2 times AM. Perpendicular from center bisects the chord. This can be written as perpendicular through the center. Okay, change it to through the center. That makes a sense. Perpendicular through the center bisects the chord. So AB equals 2AM. Therefore, AB is equal to 2 times R into sine theta by 2. So we have got base. What about height? Again, in the same triangle, cos of theta by 2 is equal to, in the same triangle OAM, cos of theta by 2 is equal to adjacent side by hypotenuse, OM by OA, OM by OA, which is equal to OM by OA is R, implies OM equals R cos theta by 2, R into cos of theta by 2. So I have got here, what is this one? I got here the base AB and OM height. Therefore, area of the triangle. Now, area of triangle, which triangle? OAB equals half into base AB into altitude OM, which is equal to half into, what is AB from here? 2R sin theta by 2, 2R sin theta by 2 into OM is R cos theta by 2, R cos theta by 2. So here 2 and 2 cancels, therefore I will write area of triangle OAB equals R into R square sin theta by 2 into cos theta by 2, R square into sin theta by 2 into cos theta by 2. So this is triangle, area of the triangle OAB. Mark this as 3. So substituting the values of 2 and 3 in 1, we get, substituting 2 and 3. What is 2 here? Area of the sector OAPB 2, and 3. What is the area 3 here? It is area of the triangle in equation 1. Substituting 2 and 3 in equation 1, we get, check now, area of the minor segment, which is equal to, what is the area of minor segment? APB. So here also I will write it, area of the minor segment APB करके लिख देता हूँ, APB is equal to area of the sector minus area of the triangle. Area of the sector is how much? Theta by 360 pi r square. Theta by 360 into pi r square minus area of the triangle r square into sin theta by 2, r square into sin theta by 2 into cos theta by 2. This is the expression for area of the minor segment. This you have to remember it. Simple formula, it is area of the sector minus area of the triangle. What is the area of the sector? Theta by 360 into pi r square. And area of the triangle, therefore you must remember area of the triangle over here is r square into, this is not minus, okay, this is r square dot मतलब मैथमेटिक्स में into r square sin theta by 2 into cos theta by 2. I hope you are able to understand how to calculate the area of the minor segment. What about the area of the major segment? सिर्फ ये थीटा चेंज कर दो बस हो गया. That means see here, if theta, instead of theta, if I consider this major segment to be angle, see other way you can do one more thing also. First calculate the area of the minor segment, then area of the major segment is equal to area of the circle minus area of the minor segment. That is much preferable, which I'll write here also. Area of major segment is equal to area of circle CIRCLE minus area of minor segment, because you know the angle here theta of the minor segment or the minor sector. So area of the major segment is nothing but this much and all this, including this entire region, excluding this one, which is area of the circle minus area of the minor segment. This is how we can work out. Or see, sometimes they may give you directly the angle here. Say for example 240 degrees. If they give you that way, the same formula is applicable. What is that one? Area of the major segment is equal to theta, or if I consider that is to be alpha. So alpha divided by 360 into pi r square minus r square alpha by 2 sin alpha by 2 and cos alpha by 2. There is no change with respect to that, but preferably you can do this way also. Say if they give 240 degrees, you can calculate it as 60 degrees here. 120 degrees, isn't it? Yeah, 120 degrees, because 360 minus 240, 120. So theta by 2 is 60 degrees, you can get it. So it is very easy to find out the area of the minor segment. Area of the circle minus area of the minor segment gives you area of the major segment. So these are the formula which you have to note it down. This also mark it and note it somewhere in your notebook. So in one go I completed the areas of the terminologies related to the circles like tangents, chords and secants, etc. Then we took the circle, area of the circle, circumference, and then we took the sector, area of the sector, minor sector as well as major sector, and how to calculate the length of the minor arc and length of the major arc. Then we took the segment, area of the major segment and area of the minor segment. We calculated the area of the minor segment using this formula, where theta is the angle subtended by the minor arc at the center, or the theta is the angle of the sector, you can say. So we finally concluded with the area of the minor segment as well as area of the major segment. I think nothing more to discuss. A few more couple of conceptual points are there, such as the distance covered by a wheel and the angle subtended by the minute hand in a clock and angle subtended by the hour hand in a clock. Couple of things are there. I'll discuss all those things so that the theoretical part is complete in all respects and we will be ready to solve the numericals. So first make a note of all these things. Just a moment, I'll write this here. I'll put it here. So make a note of this. Now we'll see another couple of things with respect to wheels and what is the distance covered by a wheel in one revolution, and how to find out the RPM, that is called revolutions per minute. We'll see those things. With respect to wheel, first one is the distance covered by wheel in one revolution is equal to circumference 2 pi r. In one revolutions, for example, if this is the circle, so if I start from point A and comes back to point A of radius r, in that case the distance covered by the wheel in one revolution is 2 pi r. So similarly, distance covered in n revolutions distance covered by the wheel in n revolutions is equal to 2 pi r into n. This is one more formula. Then one more formula you have, it is how to find out the revolutions per minute, RPM. RPM, it is called revolutions per minute. REV here it is revolution. So RPM is equal to, RPM of the wheel is equal to distance covered in 1 minute divided by the circumference, which is 2 pi r. So this is one more formula. What else is required? Now here one more thing is area swept by, the area swept by, I think area swept by the cylinder, it is not here, probably in mensuration, surface areas and volumes we will discuss, I think that part we will discuss there. So with respect to wheel, the distance covered by the wheel in 1 revolution, distance covered by wheel in n revolutions of radius r, and how to find out the revolutions per minute, RPM is equal to distance covered in 1 minute divided by 2 pi r. This is one important formula which you have to remember. Fine. Next, another couple of things are there. Only after that one we are ready to solve the numericals. See here, angle swept by, this is minute hand and hour hand. Next one is minute hand and hour hand. In a clock, here we would like to know the angle swept by the minute hand and the angle swept by the hour hand. First one, minute hand, which is the larger one, isn't it? The minute hand is the larger one. Suppose this is the minute hand here, this is at 12 here. It will make one complete revolution. It will make one in one minute hand will make one complete revolution in how many minutes? 60 minutes. So 60 minutes corresponds to 360 degrees. So 1 minute corresponds to how many degrees is the question. So 60 minutes, if I write here minutes and degree, 60 minutes correspond to 360 degrees. So 1 minute corresponds to x degree, and therefore 60x is equal to 360 degrees into 1. Therefore x equals 360 divided by 60, which is 006. So in 1 minute the angle swept by the minute hand is 6 degrees. Therefore angle subtended by, or angle swept by, that is the right word, angle swept by minute hand in 1 minute is equal to 6 degrees. Remember that. Clear? Next, B, hour hand. It is a shorter hand. Let us take once again the clock here. So this is the hour hand. One complete revolution, revolution of this hour hand corresponds to how many hours? It is 12 hours. This is 12 here. So 1 will be there, 2, something like this, all this reading. So this R hand will have, or the R hand will undergo one complete revolution in how many hours? In 12 hours. That means in 12 hours the angle swept by the R hand is 360 degrees. Is it right? So in 1 hour, what is the angle swept by the R hand? We'll see that one. So here I'll write R's and angle. In 12 hours, the angle swept by the R hand is 360 degrees. So in 1 hour, X implies X equals 360 divided by 12, which is 30 degrees. And then 0, correct? So 30 degrees. X is equal to, therefore I'll write here, therefore angle swept by R hand in 1 hour is equal to 30 degrees. Is it correct? So angle swept by, for example, it will undergo one complete revolution, R hand I am talking about, in 12 hours. 1 hour, 2 hour, 3 hour, 6 hour, then 9 hour and 12 hour. So it will undergo 12 hours in one complete revolution. So 12 hours corresponds to 360 degrees. So 1 hour, that means this will be here. This will be here. So what is the angle swept by this? What is this angle is the question in hand. And therefore in 1 hour means this R hand will be on position 1. You got it? So in 1 hour it will sweep an angle of 30 degrees. 360 divided by 12, X is equal to 360, X is equal to 360 by 12, 30 degrees. Now one more thing very interesting here, that may not come into our exams at all. My question to all of you is, in 1 minute, what is the angle swept by R hand? So in 1 hour, angle swept by the R hand is 30 degrees. So 1 hour is basically 60 minutes. 60 minutes corresponds to 30 degrees. Therefore here also, here I'll write angle, or I think here it is better. Here I'll write angle swept by R hand in 1 minute is equal to 30 degrees divided by 60 minutes, which is equal to 0.5 degrees or half minute. You can say half degrees. How is that? In 1 hour 30 degrees. 1 hour is equal to how many minutes? 60 minutes. So in 1 minute angle swept by the R hand is 30 by 60, half degree. That is not of much relevant. It's it's not required. Just keep it in for your information. Now why are we studying all these angles swept by the minute hand and R hand? See, one simple question I'll ask you. What is the area swept by the minute hand in 5 minutes? See, this is the question. Here we'll solve this. See, all these things you have to make a note. Okay, here I'll solve one example here. What is the area swept by minute hand in 5 minutes? Size of minute hand is size of minute hand is equal to how many centimeters can we take it? 7 centimeters. So the question here is, it goes like this. We have a clock here and this is the minute hand, r equals 7 centimeter, because size of the minute hand means it is radius. Radius of the minute hand is 7 centimeter. In 5 minutes, what is the area swept by this minute hand is the question. So it will form a sector over here. Here this will form a sector, this one. So this theta, this is theta, and this is r. R is equal to 7 centimeter, and theta is equal to, what is theta equals? See, minute hand, it will sweep 6 degrees in 1 minute. Angle swept by minute hand in 1 minute is 6 degrees. So in 5 minutes, what is the angle swept by the minute hand? 6 degree in 1 minute. For 5 minutes, 30 degrees. So here angle theta is equal to 30 degrees, because angle swept by, you can write all those things. I am taking a shortcut here. Angle swept by the minute hand in 1 minute is 6 degrees. So in 5 minutes it is 6 into 5, 30 degrees. So theta is 30 degrees. R is equal to 7 centimeter. So area of the sector, this is O here, this is A, here A. So area of the sector OAB is equal to theta by 360 into pi r square, which is equal to, theta is how much? 30 degree. 30 divided by 360 into pi is 22 by 7 into 7 into 7 square centimeter. So 7 cancels, 0 0, 3 1s are, 3 12s are, and 2 6s are, 2 11s are, which is equal to almost 77 divided by 6 square centimeters. I hope you are able to understand. So why are we discussing all these things? Angle subtended, angle swept by the minute hand and r hand. You are going to get the questions something like this. What is the area swept by the minute hand in 15 minutes? The area swept by the r hand in 6 hours, something like that. In order to know, we need to know all these things. In order to understand that, we have to know all these things. So make a note of this thing. Very important is distance with respect to the wheels and the RPM, distance covered by n revolutions, and with respect to minute hand and r hand, how to calculate the angle swept by a minute hand and r hand in a particular in 1 minute and in 1 hour basically. So make a note of all these things. Let me put this here. Okay, make a note of this one first. So one more concept we have to understand here. This is the area enclosed by 2 concentric circles. Suppose we have one circle like this and another circle which is concentric, O, and this is the radius small r and the radius capital R. Small r is the radius of circle C1 and capital R is the radius of circle C2. This area this is the area bound by 2 concentric circles. So area enclosed by 2 concentric circles. This area is also called area of annulus, ANNULUS. What is annulus here? Basically, annulus means it is a flat circular disc. Flat circular disc. It is also referred to as area of track, circular track, area of circular track, and therefore area of the annulus is equal to area of annulus, okay, is equal to, that means area enclosed by these 2 circles is equal to area of the outer circle minus area of the inner circle. What is the area of the outer circle? Pi into capital R square. Area of the inner circle, pi into small r square. So the difference of that will give you the area enclosed by the 2 circles, which is also called the area of the annulus, is equal to area of circle C2 minus area of circle C1. So this is pi capital R square minus pi small r square, which is equal to pi into bracket r square minus r square. For all calculations purpose, we can expand this also as r plus small r plus r and r minus r plus r into r minus r. That way you can do the calculations, but for the time being, please make a note of this one. What else is required? I think we have discussed almost all the basics of this chapter, and we are ready to solve the numericals. So I would like to end the lecture over here. All this constitute the basics of this chapter. So make a solid notes of this one, pause the video and make a good notes of this, and in my next lecture I'll be taking the numericals. With respect to numericals, of course R.D. Sharma contains lot of numericals and previous year questions, which is very important to solve. But according to me, also equally important are all the numericals that have been given in your NCERT textbook. So my objective will be first to concentrate on all the example numericals and the textbook NCERT numericals. First I will solve all those from next lecture onwards, and then I'll pick up only the selected few questions from R.D. Sharma. Especially at the end of the chapter in the R.D. Sharma, you have very typical sums. Those things I'll be taking into account. So make a note of all these things and see you in the next lecture with NCERT example numericals as well as exercise numericals. Thank you very much for watching.